So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 269 and we continue with our exercise. In our last video we stopped here where I discussed the first question and it was create a class and use all good practice. But now we go straight into our second question and I want you again that you read the question, stop the video, try to answer as good as you can and don't worry about if it's correct or not correct because we check it anyway. And our goal is still to learn this documentation, because when we learn this documentation and later even the original documentation, then you don't have to ask anyone and rely on anyone. Then you can just read all for yourself, see how it is defined, how to use it, and then you can teach other people how it is and check it for yourself. So that's very important that you are training this. So with that said, let's get into it. First of all, here's the question. It says here, what is the difference between class and struct? I wanted to pause the video fast and try to answer it. And of course I pause it not and I go here to my answer. And if I jump to my answer, which is the second part here, let's uncomment this fast. Control K-U for uncommenting in Visual Studio. Then I have here some answers. The first answer which I gave is public's vs private access specifier. I hope you know this. That's very important because we know the class has by default private access specifier and struct has by default public access specifier. And the question is now, why is this so important to know about this access specifier? And the answer is, we learned already also inheritance, right? So let's go here back to our example house. You can see this is class, and to this one, if I would not specify here this access specifier public here at top, this would be automatically what? Private, because this is a class. If this would be a struct, this would be automatically public. That's this access specifier. So far so easy, but don't forget we have inheritance. Later I could inherit from this class, and how I inherit this, let's just copy this one because I'm a little bit lazy. Copy this one and paste it here. And I'm just writing here, where is it? Oops, where I copied it. I copied it here. Anyway, its house is here. I copied it here. Let's call it just house 2 to make it easy. And then I would have here 2 for the constructors. And you see, I created here a second class, but I want inherit from this one here. So let's inherit how we inherit again here. And then I write from house. And now, you see this difference, class and struct makes here a difference. We talked about this. If this is a class, this here becomes automatically private inheritance, and then you know what private inheritance means. We will talk this about in other questions. And then if this would be a struct, this would be a public inheritance. And then we have to check how this public inheritance works for this one. Okay, so that is also a very important part here to know that inheritance is important. All right, so we have this one, we have inheritance. And then let's see what we have here, what I said here, and general use case of struct for variables. That one is new. This is probably which you know, which we have not discussed in this tutorial in depth. I mentioned it probably one time, and that is structs are used in practical case for certain things by many programmers, and that is a so-called pod class or aggregate initialization. We have not talked about this. First of all, what is an aggregate initialization? Here is an example. We will not dive into in this video. I will just give you a fast overview of it. You see, it's just a struct. We create a struct, and then this one you can ignore for a moment. That was something which I wanted to show you later. And then this struct has just variables in it. No constructor, no virtual specifier or whatever, just plain variables. And if you have this kind of version, you can make in and it is creating an object here. I create an object about this one here. You can see this. And interesting is what I do after this one, this initialization part. Why is this so interesting here? Think about this one, pause the video and try. I know you don't know it, but try to know why is this strange, what we learned so far. Look this again, struct egg, there are only variables, nothing else. And here I create an object and I assign values to it. Why is this so strange? The answer is because normally we need a constructor for it. We learned so far that when we create a struct or a class, you need a constructor. The constructor will take these values and assign it internally, right? And that is the new thing with aggregate initialization. You don't need that. You can just create a struct, or even a class works with a class as well. You can see here, and then do this. But here is our difference. In class, you have add to make this public because, again, access specifier class is by default private. So you have to add this one. And in practical use case, that's why they often use struct instead of class, because it's by default public. So with other words, they don't need to add this one here. And they just create a struct, add the plain data, which are most time just variables. And then they can use this aggregate initialization. And I showed you here something else. For example, if you provide a constructor, that is what we normally would do, this aggregate initialization is not working because this is not allowed. Because now you have a constructor and the constructor's job is say, I'm creating this one here and I will define how to assign these values. So let's jump here fast to this page. Here is the, we have here, let's see where I am. This is classes. When we go down, here is this word pod, which we have to discuss a little bit more in depth. This is what they use in practical. And when they are saying pod, POD stands for plain old data, and plain old data means more or less like that what I showed you here. You have only, most time, only variables in it. Nothing else, no constructor, no virtualization. There are many rules which says you are not allowed to do, or it will not work like this. And this kind of rules you can read here in, this is again this one, oops. And then these rules you can read here in aggregate initialization. We will talk about this one too in depth in another video. You can see there is a lot of examples which we have to go through and try to understand. But in short, this pod class here, this one here, it is saying just there are some requirements. And for example, you should use no virtual function, no virtual base classes, no access control, and these are just restraints. With other words, it comes down that you are using in the end just variables in struct or in the class, and the only here different is this access specifier. All right, and actually there are more differences because at the start of this tutorial I said class and struct are very similar. They are still very similar. They can be interchanged almost, but you can see now bit by bit where the differences are, where you have to be a little bit careful, and there are much more differences in other places, in certain places where you have to be careful when you are doing specific things. All right, I hope that that you answered the question as good as you can, and you see we will extend our knowledge here. So I think that's enough for this video, and in the next video I will go this one here to the next question, describe important part of a class, and this one here just a tip. You can, if you don't remember important part of a class, go just to the class section Then read here one time through and try to see if you remember the most of them. Or better, try to answer this one here first and then read through this one, because here are most parts are listed. I think not all parts, but most parts, because inheritance is here also not, and so, but yeah, that's in the next video. And if you have any questions, like all time, write in the comment section. See you in the next video. Have fun, and like all time, never give up. Bye.